Hello, and welcome to our next e-learning lesson, which is Unit 10, Lesson 2 on finding arc measures. This is part 1. This week you will have 2 assignments to turn in, and the first assignment will go with this video, and the second assignment will go with the second video. All right, here we go. We're going to talk about what it means to be a circular arc. So if we had a little bit more time, we would have in class, we would have made all of these circles, and there is a measurement tool that would allow us to measure the angle, and then we would have been able to measure the arc. And what's important for me to kind of start with is that arcs can be measured in 2 ways. So an arc is just, if we have a circle, an arc is just going to be a piece of it. Think of it kind of like the crust on a pizza, or think of it as the crust on a piece of pie. Arcs can be measured in terms of their length. So like how many centimeters, how many inches it is, but they can also be measured in degrees, just like we measure angles. And what we're going to notice is that whatever the measurement of the angle is, so let's say this was 30 degrees, then we would also say that this is a 30-degree arc measurement. So we call what I have written in blue, this is called a central angle. It's called a central angle because the angle has a vertex that is in the center of the circle. Center of the circle, central angle. So let's go to our definition. The measure of a minor arc is the measure of its central angle. And when you name a minor arc, this is important. A minor arc is always named with 2 letters. This is important because if I look at a circle with center C, and this is A and B, how do you know if you want to talk about this arc, or how do you know if you want to talk about this arc? Well, a minor arc is always less than 180 degrees. So it's always the small one. It's minor. It should have 2 letters. So in our example here, the measure of arc AB, so the measure of arc AB, because it is 2 letters, we're looking at the smaller version, the smaller piece. Since its central angle is 50 degrees, its arc is 50 degrees. When I want to talk about a major arc, the major arc is going to be larger than 180 degrees, and it is going to be named with 3 letters. So notice when we talk about the measure of arc ADB, we have 3 letters, and we've got that arc symbol underneath. So we don't use a straight line. We don't put arrows on it. It's not a ray. We use an arc to denote that it's an arc. So let's do some examples. Find the measure of each arc of circle P. So this implies that P is the center, where RT is the diameter. If RT is the diameter, we know that it's cutting the circle in half. And if there's 360 degrees in an entire circle, we know from R to T and from T to R that's 180. That is going to be pretty important information. Okay, let's do A. On A, it wants us to find RS. I know it's a minor arc and less than 180 because there's 2 letters. I notice that if I trace the arc or the angle that forms that arc, so if we're talking about RS and I look at the angle that subtends it, that's the word I'm using for the arc and the angle, well, those 2 measurements have to be the same because the central angle is equivalent to its arc. So this is 110 degrees. All right, next, they want us to find RTS. Since there are 3 letters, that means I'm not going R to S. All right, I'm not doing that because that would be a minor arc. Go in the order that they gave you. They want you to go from R to T to S. Okay, well, let's think about that. If we are told that RT is the diameter, then from here to here, this has to be 180. So if this is 110, that would make this 70 degrees. So if I want arc RTS, R to T is 180, T to S is 70. So that makes that arc a 250-degree arc. All right, now let's do C. On C, they want us to find arc RST, and since that's a half a circle, that is 180 degrees. So we just used the arc addition postulate on B here. We took arc RT that we knew was 180 and we knew S to T was 70 and added them together. So the measure of an arc formed by two adjacent arcs is the sum. So just like we have with segment addition, if this is 5 and this is 7, it makes the whole thing 12. We have that same idea with arcs. Okay, so I'm going to give you a strategy. When I do these problems, I try to fill in the missing information before I go and answer the questions. So you want to look and see what you don't have. So I notice that before I answer any questions, I don't have this angle. But what I do know is that if I add up all of the angles, it should equal 360 because there's 360 degrees in a circle. So if I take 40 plus 80, that's 120, plus another 110 is 230. And if I subtract 230 from 360, I get that that is 130 degrees. Okay, so I'm going to fill that in. We know that this is 130. Let's start answering our questions. All right, they want you to find GE, G to E. I'm not going to go the opposite direction because if I went the opposite direction, that would be a major arc. That would be over 180 degrees. And since there's two letters, I know I want the minor arc. Well, when I traced that, I went a distance of 40, and then I did 80. So 40 plus 80 gives me a total of 120 degree arc. But when I want GEF, all right, I'm going to go to G, I'm going to E, and then I'm going to continue to F. That's a major arc. I should expect an answer that is more than 360. You guys, you have two ways to go about it. One way that you could do it is add up 40 and 80 and then add up the 110, and so I get 230. That is the final answer. But alternatively, you could have said, well, there's 360 degrees in the whole circle. You haven't used up 130, and you could have subtracted 130 to arrive at that same result. Now we want to find GF. So when I look at GF, all right, we have already discussed by adding them up and subtracting from 360 that that is also 130. A recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. It's getting late. All right, so looking at this, I'm going to look at AC. So again, I know that you can go from A to C this way, and you can go from A to C this way, but because there's two letters, I need to take the minor arc. So I'm going to be looking at the arc that is less than 180 degrees. So from A to C would mean I'm going to take 29 plus 108, and 29 plus 108 gives me 137. Next, when I want to look at the measure of arc ACD, that is going to imply that it is going to be a major arc. So when I look at A to C to D, I'm going to have to add up 29 and 108, which we know is already 137, and I'm going to add another 83. So I am getting 220 degrees for arc ACD. Next, they want arc ADC. ADC. Again, you could do a variety of things. You can add up 79 plus 61 plus 83. Alternatively, we've already discussed that AC is 137, so you could also take 360 minus 137. So if I take 360 minus 137, that arc is 223. $79 plus 61 plus 83, 79 plus 61 plus 83 also gives me 223. Last but not least, the measure of angle EBD. Let's get a suitable color here. So we go E to B to D. I think the easiest way is to do 360 minus 61. Whoa. And we get 299. All right, so what I would do at this point is pause this video and then see if you can do the next 6, then hit play, and then see if you get the correct answers. And friends, we are going to go ahead, and if it is a half a circle, we call that a semicircle versus a major arc. All right, the congruent circles theorem. Two circles are congruent if and only if, you guys, they have to have the same radius. If they don't have the same radius, they are not congruent. Furthermore, this congruent central angles theorem says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So let's look at the next set of examples. It wants you to tell you whether the red arcs are congruent and explain why. Let's look at A. If I look at this angle that it cuts off and this angle that cuts off, you have two central angles cutting off the same arcs. Therefore, the congruent central angles theorem applies. So yes, by the congruent central angles theorem. B. When you look at B, you have to be very careful. In order for anything to be congruent, the two circles have to have the same radius. So if I look at this circle, here's its radius. But if I look at the larger circle, here's its radius. These are not congruent circles, therefore those arcs are not congruent. And problem C. This is pretty important information. This tells you that the radii are the same. This tells you that they are congruent circles. So we know that they're congruent circles. And then if we look at theorem 10.4, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Since their central angles are congruent, yes, the red arcs are congruent. Two more. I like these problems next to each other because the main differences between the two is in problem 7, they told you that the radii are congruent. Radii is plural of radius. So that means in problem 7, your circles are congruent. But in problem 8, they told you that in the first circle, the radius is 5, and the second one is 4. Here, the circles are not congruent. So even though they have the same central angle, if your circles are not congruent, your arcs cannot be congruent. So no, the arcs are not congruent. Versus in the previous problem, because they are congruent circles, and I have the same central angles, then yes, I can say that the two red arcs are congruent. And to conclude this first video, we do have a similar circles theorem. So all circles, they're similar, meaning they would be proportional in, they would have proportionality in their measurements. So at this point, we have concluded our first video, and you can complete Unit 10, Lesson 2, Practice A. I will rejoin you in the second video.